Okay, today we're going to talk about naming ionic compounds. And first, there's lots of different ionic compounds. There's ones with polyatomic ions, and then kind of like the easier ones are just these ones from the periodic table, like fluorine, chlorine, iodine, and bromine. And then, of course, we have the ones in the D block that we're going to also talk about today. But definitely ionic bonding is the easiest, wouldn't you say?
It is the easiest.
Covalent bonding, there's also sorts of, we have to tell how many, and
Right.
there's all sorts of other things involved. But ionic bonding is pretty straightforward. And so we're going to go ahead and write out the rules here. So first one, just like when we're writing the formula, the cation goes first. And you always just write out the name.
Name.
Yep. And you don't have to change anything. So you don't have to put any kind of number with it. It's just sodium. So this one literally is already written out. So let's go ahead and put this one in the formula so we have an example to do.
So we know sodium is in group 1.
Group 1, so that's going to be a positive 1 ion. It's likely going to lose an electron when bonding. Positive 1.
While sulfur is in group 6.
Group 6, so it needs 2 more electrons to have 8, and so 2 electrons would make it negative, so it's going to be a negative 2. Crisscross these. We could do the electron dot structure, but really that's more of a visual thing. You should be understanding this good enough that we can just quickly look at this and say, so sodium is going to have 2, and the sulfur, there's only 1 of them.
This one.
So what we're really interested in is naming this guy. Okay, so from now on you're either going to have the name, which I'm teaching you how to do, and you have to write the formula, or you're going to have the formula and you have to write the name. One of the two. Alright, so if we're going to follow our first rules, cation goes first, so we'd write sodium, we just write out the name. So the name for this would just be sodium. And then the anion has a little bit of a difference.
Anion goes second, obviously. Alright, but we're going to change the ending of sulfur to ide.
Anion ending changes to IDE. Okay, and a great example of this is this chart right here. So these are just elements from the periodic table. Fluorine. Fluorine changes to fluoride. Chlorine changes to chloride. Iodine changes to iodide. And bromine changes to bromide. Okay? So for this ending, if it's sulfur, we're going to change it to
sulfide.
Sulfide. And usually wherever the vowel is before the ending is where you kind of lop it off. So this is the vowel before the ending, so that's the part that you would change into ide.
Right.
Okay, and so when it's an ene, that's really easy, but like something like sulfur, this is where you would lop it off. Okay?
Right.
So sodium sulfide is how you would name it. So let's go ahead and practice this. So if you have K and L, let's go ahead and write the formula first.
Okay.
K is what element?
Potassium.
Potassium, and it's in group 1. It's a positive charge.
Chlorine is in group 7, so it has a negative 1 charge. Alright, crisscross. We do 1 for each. We just have KCl.
Okay, so to name this, we're going to write our cation first.
So it would just be potassium. And when we're looking at our anion, chlorine, we have to lop off the end and change it to chloride.
And here is where I'd put that INE, but this time I'm going to put IDE, chloride. Okay? Aluminum and bromine.
Aluminum is Al. It's in group 3. So it's going to give away 3 electrons, so it's 3 plus. Alright. Bromine, that is over in group 7. So it's going to want 1 electron, so it's going to be a negative 1. Okay. Alright, crisscross. Writing out our formula will be Al3 or excuse me, Al. Sorry. AlBr3.
VR3.
It didn't have itself.
It's okay.
Okay. So now we're looking at writing it out. Our ionic name here. We have aluminum.
It's 1M or yep.
Yep.
Okay.
Aluminum, and then our anion goes second, and we change it to bromide.
So this is where the INE would be, and I'm changing it to ide. Okay. So anything on the periodic table, if you're looking at it and you're getting the anion, if anion is from periodic table, the ending is always ide. And I think that even holds true in covalent bonding. I mean, yeah.
Yeah.
Ending is IDE. Okay? That's always the case, alright? So make special note of that. Okay, because there's polyatomic ions, we're not going to have this ide ending.
No.
They have the special endings dealing with the number of oxygens they have. So, but if it's from the periodic table, we know the ending is ide. Alright, let's do one more here.
Alright, lithium, that is in group 1, so that's a +1 charge. Nitrogen is in group 5, means it is -3. Crisscross. Writing out our formula, we'll have Li3, and then just 1 nitrogen.
Okay, and we don't have to put like aluminum 3 bromide or tribromide or anything, because no matter how you write it, if it's in the name, we're using the periodic table to figure out this number.
Right.
We're actually using, you know, the math of crisscrossing it and figuring out how many ions or electrons that it needs.
Right.
So in ionic bonding, we don't have to put the number. In covalent bonding, you can have any kind of combination that you want. So we have to tell how many.
Exactly.
But ionic bonding, we have these ions that we use, and so we don't have to. Okay? So now we can just write lithium by itself, and then
Tried.
So this would be where the O would go. So that's the first vowel before the ending. So this is where it would change to ide. So lithium nitride. Okay. So now let's look at naming with polyatomic ions. So now we have the sulfate ending. Okay, and this is really actually going to be even easier because polyatomic ions, we don't change anything. And we already said that cations don't change in ionic bonding. So this one we'd have barium's in group 2, +2 ion, sulfate, SO4, and it's -2 charge. And this is something that I didn't mention on our first video, which I should have. When we crisscross something and it's Ba2SO4, and of course we need parentheses here, 2, and these are both 2s, they cancel each other out.
Right. I think the example was the magnesium oxide.
Yep. And so these guys cancel out, and so it's just BaSO4 on that. Okay? And so we would just name this. It's kind of silly because we had it written already, but nothing changes. And so the name of this literally is barium. I guess you'd take out the and.
Yes.
Barium
sulfate.
And that's the name of that ionic compound.
Right.
So aluminum is +3, chromate -2. Oh no.
I believe.
Oh no.
Yes, it is -2.
Okay.
It's -2.
Couldn't remember for a second. Haven't looked at these. I know you guys are like, oh, be quiet. All right. So now we have Al2CrO4. Now you have to keep this together.
Right.
Okay. You can never just say, oh, that's not important. This is a bond. You have to keep this together all the time. And so
now have 3 of them.
Now you just have 3 of these covalent bonds attaching to 2 aluminum. Okay, so now we have this, and we're just going to write it out as aluminum. And this is why you have to know the names of these.
Right.
This is why we took the quiz, because this will be on your test, and like this, you'll have to name it. So this is aluminum what? Chromate. But if you don't know that, you're going to put chromium oxide or some crazy thing like that, and it's going to be wrong. Trust me, I've seen it. Whoops. Oh wait, chromate.
8.
Aluminum chromate's the right answer there.
If you don't know what CrO4 is, you're in a lot of trouble.
A lot of trouble. Okay, so this is potassium, and it's a positive 1 charge. We have permanganate, which is
MnO4. Negative charge.
-1. And this is actually this over here. This is potassium permanganate, and Mr. Fitzsimmons reminded me of this cool compound. It's purple.
Yeah, very purple. Stains things, stains you. You get it on yourself.
But we use it a lot in science.
Yep.
So this is a 1-to-1 ratio. So our formula is KMNO4. And to name that, I mean, this looks confusing to name if you don't know your polyatomic ion.
Right. If you don't know what MnO4 is,
you're completely confused. Yep. So this is potassium
permanganate.
PTE. Whoops.
Yep. Just forgotten.
In here? Yep. Okay. Permanganate. I'm not going to count you off if you're getting in. Okay. Yep. But also, if you have this, you have to be able to write this formula, just like we did from there. So that's why it's really important to know permanganate is MnO4. You have to know that. All right, and then calcium is a positive 2. This guy right here, you have to know what he is. That is hypochlorite.
Right.
Hypochlorite. And he's a -1 charge. Crisscross, and we get Ca with just one of those.
Yep.
And then ClO2. Now, if you just put the 2 there, that indicates that there's two oxygens, which would actually make it chlorite instead of hypochlorite. So that's a big mistake. It changes it entirely. So that parentheses, really important. So now this is calcium hypochlorite. Okay, so many elements have to have the ite, have to have the hypo, and then in the formula you would have to have the 2 there. All right. So now we have to talk about oxidation numbers.
Right. And
oxidation numbers really are just oxygen being a jerk and getting in the way of everything and changing. Yeah, he literally changes. Triangle means change. Changes the number of electrons. Okay, in all sorts of things, especially metals.
Right.
Especially transition metals. Like iron and copper and nickel and cobalt. Okay.
Everything cars are made out of. So if you see car rust, that's oxidation happening.
And transition metals, which if you've forgotten, hopefully not, those are in the D block. Okay. But it doesn't have to be the metals. We see oxidation happening all over. Okay. Right. This is when your apple turns brown or your bananas turn brown.
Right. Anything exposed to the air.
Right, and even they think this is one of the main reasons for aging for humans.
Yes.
We oxidize as well. Okay, and so basically we have to treat these D block elements a little differently. Okay, so if we've forgotten, D block is right in here. Okay, and basically there's a little stair step right along here that all of these require an oxidation number. Now this isn't so bad because you'll see them and they'll have this oxidation number. But when you're writing them in the word, you have to remember to put the oxidation number in there. And that's really the most difficult part. Yeah. And this oxidation number is represented, oxidation number means charge. Okay, this is the charge because you can't use the group number. Nope. So we have to use the oxidation number to find the charge, and that is a Roman numeral. Oops. Okay, so let's go ahead and investigate this a little bit. So nickel here, we don't even have to use the periodic table because this Roman numeral is telling us the charge. Okay. Now, my most common mistake that I see all the time is that nickel, you'll see this 3 and you'll automatically write nickel 3. And
Subscript, no.
Yeah, and that is completely incorrect. Nickel, there's not 3 nickel. Nickel has the charge of 3. Charge, 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 charge. Not how many. It's the charge, not how many.
It's the charge, not how many.
It's the charge, not how many. Okay, so we'll move on from that point as long as you understand that it's the charge.
Not how many.
Right. Okay, here we go. So now we know that nickel has a positive 3 charge and chloride has a negative 1 charge. Crisscross those.
Crisscross.
And now we have NiCl3. Okay? So that's easy enough.
Yep.
In fact, that is the easiest when it's there for you, and as long as you can remember that's the charge and not how many, then it's fairly easy to get the right answer. Okay, now this is where it kind of gets a little more difficult, is when they are in formula. And so you have to see this W and be like, oh, W is in the D block, which is a transition metal, which has an oxidation number. Well, how am I supposed to find out that oxidation number? Because it doesn't tell me, because when you write it, so we find out that W is actually tungsten, which is my favorite element. It's my husband's wedding ring, just FYI. Yep. So tungsten, then now we have to kind of work backwards. We have to do the reverse crisscross. Okay? So now you have to take this up here and this up here. So now this is saying that oxygen has a negative 2 charge. Is that true?
Right.
And so what must be tungsten's charge?
Positive 5.
Positive 5. That's correct. So now you would write
5, which is just a V, Roman numeral.
Roman numeral 5.
For the charge.
And then just write out the anion with an "-ide" ending. Okay, because that's what we've been doing. You still have to carry that over.
Right.
Now that's absolutely the most confusing one you'll have to do, is when you have to figure out the charge and do the reverse crisscross. Okay, because you'll look at this and you'll be like, what? How am I supposed to write that? Have to do that. Have to tell the charge of this. Otherwise, if you were just to write tungsten oxide, we would have no idea how many we would have. Alright, so let's do this next one. This is 2, so we'll put a copper as a positive 2 charge. Sulfide's a negative 2 charge. Sulfide, notice that it says fide. So that's sulfur. You got to recognize that as sulfur from now on. So now we're going to have Cu and S. Okay, and that's no different than anything else we've done. We just have to recognize that "-ide" ending and know that that's the charge and not how many.
Right.
Okay. All right. Here's another one we're gonna have to work backwards on.
Right.
Okay. So reverse crisscross. This means oxygen has a negative 2.
Correct.
And this 3 has a positive 3.
Right.
Okay. So now this is iron.
3.
Oxide. Okay? And sometimes people write iron too, because they'll see this number of how many, and it's wrong.
Yep.
Okay?
It's not a Roman numeral. It's not charge.
That's right. Alright, so here this is a positive 3, and of course this could say nitride, so we know this is a negative 3, but just as easily this could say nitrate, or it could say nitrite. It could be a polyatomic ion as well, okay, because oxidation numbers can go with any of these. So we'll do nitride first. Zinc nitride, so it's just ZNN.
Yep.
Easy enough. Where nitrate now, nitrate is a negative 1 charge.
Right.
Both nitrite and nitrate, they're always the same charge.
Yes.
They just have the different amount of oxygen. So now we have zinc, and then nitrate is NO3, and this is a negative 1 charge.
Right.
This is a positive 3 charge. So now we're going to do ZN. There's one of those.
Right.
And then NO3.
In parentheses with a 3.
3. Yeah. And then nitrite, same deal. And zinc's going to be positive 3, except for now it's NO2 because it's nitrite. Is the ending. So it's polyatomic ion, so it's ITE. We know this guy is from the periodic table because it says IDE. So we know we're talking about nitrogen.
Right.
That's on the periodic table. So that these get confused a lot because we don't look at the endings. We really have to start looking at the endings of the anion. That's going to show you if it's either a polyatomic ion or something from the periodic table. So now we're going to have the same number, except for now it's going to be NO2, parentheses.
With the 3 on the end.
3.
Yep.
Right. Okay. So this concludes our naming section, and we will be taking a formative assessment over this on Tuesday. So we will have polyatomic ions on there, oxidation numbers on there, naming, writing formulas, and even a couple of electron dot structures. So make sure you're working hard on Monday to get caught up and understand what you're doing. Have a great 3-day weekend.
Yes, have a good weekend.